Videos, we are going to see how we can model an electric vehicle using MATLAB and Simulink. But before that, we need to have a basic understanding of what electric vehicles are. So, what are electric vehicles? What is the history of electric vehicles? Which types are available? Which architecture they use? Which components are involved in electric vehicles, and such things. So, moving on, an electric vehicle uh, comes into mind when we are thinking of the climate change becomes the main concern to us. So we need a more sustainable solution, and when we look at automotive industry, the very first thing comes into mind is the polluting internal combustion vehicles or petrol diesel vehicles. So they are the major source of pollution on our roads, and thus when we look for a alternative solution for them, electric vehicles comes into mind and looks like a very important option to us. Now, in this future era of technology, which is going to be truly electric, we are going to see connected vehicles, autonomous vehicles, shared vehicles, which can share the communication between them. And then we are going to see some sort of electric mobility embedded into the new design or new trend of vehicles. Now, the electric vehicle, which gives a shortened acronym as the EV, is an example of conversion of electrical energy directly to the mechanical energy. So, in case of a combustion vehicle, the heat energy, then the chemical energy of the fuel gets converted into heat, and then the heat gets converted into mechanical. So, more more the conversion, there will be more the inefficiencies. So that's why the electric vehicles are very efficient because of the electric motor, and because since the electric motor has a very good capability or a very good efficiency of converting electrical energy to the mechanical energy, electric vehicles become uh, directly very efficient. When we compare them with the electric combustion, the internal combustion vehicles. As we saw, the electric vehicles gets an acronym as a EV, short an acronym as a EV, and they are either partially or fully powered by electric motors. When we say partially powered, we are talking about hybrid vehicles, and when we say fully powered, we are talking about battery electric vehicles. Now, these electric vehicles uses one or more electric motors depending on the type of architecture or system they are using. Uh, or a single traction motor for the propulsion of these type of vehicles. An vehicle may be powered through a collector system by a electric electricity from an off the vehicle source, or say suppose an external power source, or they can use a self-contained battery which will be providing the required traction, or the required energy to the electric motors. They can use solar panels, alternate systems. You can use fuel cells, which uses hydrogen to convert hydrogen and air to convert electricity, and the discharge is water. Or they can use an electric generator, which will convert the fuel, uh, which will just simply convert the fuel or petrol or diesel into electricity, and then use this electricity to run the vehicle. So this is also one type of hybrid vehicle we are going to see. The examples will include rail vehicles, electric aircrafts. So when we say this vehicle can be powered by a collector system using an off the source energy, of the vehicle energy. So we are talking about railway vehicles particularly. So the engine or locomotive, that you may have seen electric locomotives in your city, or in the Indian Railways itself. So what they use is a very high tension electric wire at the top, and then we use a pantograph to take that power from the high tension line to the locomotive, and then there are converters which will convert that very high power voltage or high voltage electricity into a usable form, and then use that to run electric motors and give the traction to railways. Now this is very popular, and in all of the countries, and mostly wherever there is a availability of electricity, we use the electric locomotives only. The diesels are still there, but Electric is the main purpose we are using. And then we have electric aircrafts. They are they are not very popular. They are gaining traction, but they are limited. And then we have electric buses, which is very common in metro cities like Mumbai. So you will see electric buses there, which are used for a daily commuting. And then we have a personal electric vehicle car. So we have either personal or commercial as well. So personal cars, personal scooters, for personal electric bikes, or the commercial ones. So the pickup trucks and all. So we have electric vehicles in all sort of all sort of classes or all sort of vehicle types. Now, moving on to the history of the electric vehicles, the electric motive power started in 1827 when a Hungarian priest, Enos Zedlik, built the first crude but a viable electric motor, and in the very next year he used it to power a very small or tiny car. In 1835, a professor named Zybrandus Strating of the University of Groningen in the Netherlands built a small-scale electric car, and between 1832 to 1835, the exact year is unknown. The Robert Anderson of the Robert Anderson of Scotland invented the first crude electric vehicle carriage, which was powered by a non-rechargeable primary cells. So when we talk about cells, there are two types of cells available. One is primary, one is secondary. What is the difference between them? Nothing but primary cells are non-rechargeable type, so one time use only, and the other one, the secondary cells, are rechargeable. So you can use the charge, deplete the charge completely, then again charge the secondary cell and use it again. So now the cycle continues until the secondary cell can hold the charge, right? So primary cells are one time use, and the secondary cells you can use as many times you want. The first mass-produced electric vehicle started to appear in Americas by early 1900s. In 1902, the Studebaker company entered the automotive business with an electric vehicle, though they later on entered using gasoline vehicles as well. However, the advent of cheap assembly line cars by the Ford Motor Company, kick-started by their Model T, gained the popularity, and the electric cars declined significantly. And in later 1996, when General Motors launched its first EV called EV1, after a very brief successful running due to the political issues, the market got shrunk and the electric vehicles became almost non-existent in nature. Uh, the reason primarily the reason was because of the charging times. So when you compare them with a petrol powered or diesel powered vehicle, you can refuel the whole vehicle within a few minutes and use it for another 200, 300, or 400 kilometers. But in case of electric vehicles, in early 1900s or the early 2000s, the charging time was very high. So if you want to have a vehicle with a 100-kilometer range, you have to charge about 18 hours, 20 hours. So the fast charging options were not available, and which became the major reason why electric vehicles failed to gain popularity in their early days. But with the updates in the technology and the power electronics, now we have such capable systems which can charge an electric vehicle in between 14 to 15 minutes for about 100-kilometer range. So if you have a very capable power charging systems around, so you can get an electric vehicle, go to the charging station, charge it for 10 minutes, have 100 kilometers of range, and then move on. So the charging times, though little bit still very bit higher than a simple refueling of petrol and diesels, but they are to come like coping up with these systems. And again, the efficiencies are very higher. So while in a combustion vehicle or petrol powered vehicle gives you about 30 to 40% of available efficiency, electric vehicles can range up to 90% of the energy you're using. So they become very energy efficient in nature. In the next videos, we are going to see a few types of these electric vehicles, architectures involved, and the various components involved in the electric vehicle. So in the previous, we took a very brief introduction to electric vehicles. We saw what electric type vehicles are, a few types, with primary and secondary cells. A little bit brief about the history of cells, when the history of electric vehicles, when they started and how things went. Now, moving on to the types of electric vehicles. So, majorly, you can distribute these electric vehicles into three types or three categories. So, first is a battery electric vehicle (BEV). Second is PHEV, or which is short name of plug-in hybrid electric vehicle. And then we have HEV, or hybrid electric vehicles. So we will see one by one what are these. So beginning with battery electric vehicles. This electric type of vehicles does not contain any other source for traction. So they will have motors and batteries only. So the motor is powered by battery, and battery is used to store the energy. That's it. So these are the, zero emission type of vehicles. They are 100% powered by the electricity. The power battery is charged through an external source of power, such as a DC fast charge or AC chargers. They store the electricity in rechargeable batteries, or you can say the secondary cells, which is made. These rechargeable batteries are made up of secondary cells. The electric motors present in the this type of EV draws power from the storage, and the energy conversion is done from the electrical energy to the mechanical energy. Further, the mechanical energy is transferred through a proper gear system, which in turn will be used for the traction and to rotate the wheels, turn the wheels, and get the vehicle moving. Now, examples of such four-wheeler battery electric vehicles are very popular: Tata Nexon electric EV, or Tata Nexon EV. Then we have Hyundai Kona Electric. We have upcoming Mahindra EKUV 100. We have again a very popular MG ZS EV, and the two-wheeler battery electric vehicles, which will include the few popular ones are Ather 450X, TVS iQube, Bajaj Chetak Electric, etc. So nowadays we are seeing battery electric vehicles more and more. And one very popular mention is the Tesla. So the Tesla range, Tesla Model S, Model X, Model 3, every one of them are a battery electric type only. So they are 100% powered by the electricity. They use only one source for energy storage, which is a battery. Now moving on to the second type, a PHEV, or a plug-in hybrid electric vehicle. So these type of vehicles use battery to power the electric vehicle, as well as fuels. So there is a one ICE, internal combustion engine, which is powered by fuel such as petrol or diesel, depending on the type of the combustion vehicle, engine. So in term spark ignition, SI will use petrol. Then compression ignition, CI, will use diesel. Now the electricity can be electricity is generated either via braking or through the external source of power, and this type of vehicle typically runs on electric power until the battery is completely or nearly depleted, and then the car will automatically switch to use the internal combustion vehicle. So in case of a plug-in hybrid electric vehicle, you can use an external source like a DC fast charge or AC charger to charge that battery storage, and then uh, charge the storage, use that storage to run until the battery is nearly depleted. You can use the regenerative effect to recuperate the energy, or the kinetic energy of the vehicle back into the battery. Or once the battery is nearly depleted, you will switch over to the internal combustion vehicle, and then you can run your vehicle as well normally. And then the third one, we have hybrid electric vehicles. Now this type of electric vehicles are charged using the combustion engine. So there is no external arrangement to charge the battery. The heat produced by the brakes are can be converted into electrical energy, or you can use a regenerative effect of the electric motors to get back the energy, or the change the kinetic energy of the of your vehicle back into the battery in form of electric energy. Now this process, uh, what I'm saying, is called as a regenerative braking. Now the electric motor used to start off the HEVs, and then the propulsion uh, will be taken care by the internal combustion engine. So we will start the vehicle using the electric motor, and then after a certain speed, say 10 kilometers per hour or 20 kilometers per hour, the ICE will take over, or the internal combustion engine will take over. The operation of engine as well as the motor is controlled by a ECU, or called as a electric control unit. And the examples of such hybrid electric vehicles in India are Toyota Prius hybrid, which is being on sale for a very long period of time. Then we have a Honda Civic hybrid, uh, not available in the Indian markets, but available in the foreign markets. And then the very popular one, Toyota Camry hybrid. So again, this vehicle is being on sale in India for a very long time. And a very new addition to this type of hybrid electric vehicles is the Honda City hybrid, or Honda City EHEV, as the company says. So this again does not have a external arrangement to charge the battery. So the battery is charged uh, solely via the regenerative braking effect and the ICE, or the internal combustion engine. Okay, so this was all about the type of EVs. So we saw three types: BEV, PHEV, and HEV: battery electric vehicles, plug-in hybrid electric vehicles, and hybrid electric vehicles. In the next videos, we are going to dwell into this type of vehicles individually and see what are the We have started with the modeling of electric vehicle using MATLAB and Simulink, but before that we wanted to give you a very brief understanding of what electric vehicles are. So we have covered a general topic on what is electric vehicle, history of electric vehicle, and we have seen some types of electric vehicles. So electric vehicles are majorly can be classified into three groups. One is BEV, battery electric vehicle; PHEV, plug-in hybrid electric vehicle; HEV, hybrid electric vehicle. Now moving on, we will see uh, one by one which all components are involved in each class of these EVs. So the very first one is BEV, battery electric vehicle. So these are also known as the all electric vehicles. So the components of BEV are: the very first one is the traction motor, and the second major component of BEV is the traction battery. So the energy storage in this type of electric vehicle is only in the form of traction battery. Now the components involved are electric traction motor. This will provide the uh, tractive effort and tractive power to the vehicle. Then we have power electronic controllers here, and then we have DC-DC converters. So power electronic controllers will do, they will manage the motor. So when you press the accelerator pedal, how much force to be generated, and these things are controlled by the power electronic controllers for the electric motor. Then we have the DC-DC converters. So what is this thing doing? Because we have a set of particular type of a traction battery pack. So depending on the required voltages, we will be using this one. Then, but either we have to step it up a little bit or step it down a little bit for the use for traction motor. So we will be employing a DC-DC converter that will do the uh, conversion for us. So either it will ramp up the voltage or it will lower down the voltage. And then we have a thermal system for cooling part. So there is a one thermal system here. Now these will they can compose of one or two radiators, and they will do the necessary cooling for the motor as well as for the battery pack. And then we have an auxiliary battery. This auxiliary battery will be used for uh, it's basically just like a normal auxiliary battery available in your petrol and diesel vehicle. So all the accessories and so dashboard components, they all will run by this auxiliary type of battery. And then we have a onboard charger, because you can see here you can connect a external charger to the in this type of vehicle. So you will be using an off the vehicle power source to charge the vehicle and store the energy inside it and then move on. So you this type is auxiliary type of battery. And then we have a onboard charger, because you can see here you can connect a external charger to the in this type of vehicle. So you will be using an off the vehicle power source to charge the vehicle and store the energy inside it and then move on. So you will have an onboard charger for this one. And then you can either you have transmission in case of a single speed or two speed transmission. So uh, if depending on the application, usually electric vehicles don't require any transmission, because they have a very decent power characteristics. But in case you want to increase the torque, or you want to go on the higher speeds, then you may need some gears. So you have a transmission setup for this. And then this is the charging port here. And then at last we have the traction battery pack. So the majority of the floor is consumed by this traction battery pack. Now moving on, the next class we will be looking at is PHEVs, or plug-in hybrid electric vehicles. So what are the changes here? So the very first thing, this is not all electric, because this thing has an internal combustion engine. So here it is a spark ignited, so a petrol engine. Now again, now you can see here the powertrain is or the propulsion is carried out by the internal combustion engine as well as an electric traction motor here. So it will compose of a SI engine, or a spark ignited engine, or in general terms petrol engine. Then it will have electric generator and an electric traction motor. And the other rest of the things are almost the same. So power electronic controller for the traction motor and generator. Then we have the internal combustion engine. So here it is a spark ignited, so a petrol engine. Now again, now you can see here the powertrain is or the propulsion is carried out by the internal combustion engine as well as an electric traction motor here. So it will compose of a SI engine, or a spark ignited engine, or in general terms petrol engine. Then it will have electric generator and an electric traction motor. And the other rest of the things are almost the same. So power electronic controller for the traction motor and generator. Then we have a thermal system for cooling. We have an auxiliary battery for accessories. Then an onboard charger, because you can plug in this type of vehicle to the grid and then charge the battery pack externally. Then you have the transmission. Then we have these both electric generator and electric traction motor pairing. Then we have the charging port. We have the traction battery. Now notice the size of the batteries here. So the first size of the battery in battery electric vehicle is very large, and here in case of the plug-in hybrid electric vehicle, the battery is small. And then obviously we have a fuel tank as well here, because we have a petrol engine. And then we will have some exhaust systems and a fuel filling cap for to fill the fuel tank. Then the next class is the HEV, and all of these are called the hybrid electric vehicles. So again, the PHEV, the difference between PHEV and HEV is that in case of a PHEV, you can connect the external charger to the vehicle, or while in case of a HEV, you cannot connect. So there is no provision to connect a charging port to the vehicle. So again, this will have all of the similar components. So the spark ignited engine, the power electronic controller, the thermal system, auxiliary battery, traction motor and generator pairing, a traction battery pack, and the fuel tank. Okay, so the only difference here is you can connect this one, and while you cannot connect this one. And the traction battery is again here smaller compared to PHEV. So the biggest battery is in the all electric vehicle, then the size shrunk in case of PHEVs, and then further in case of the HEVs the size of battery pack is shrunk again. Okay, so we covered the major components involved in case of all electric or hybrid electric vehicles. In the next videos, we will see the various architectures involved in case of hybrid electric vehicle. So, to give a brief about these architectures, so here you have a traction motor, a generator, and a internal combustion engine. Now, this is very different from a normal perspective. So in case of a combustion engine, all pure combustion engine vehicle, the petrol or diesel one, you don't have these things, so traction motor and generator motor. So the power coming from the combustion motor is directly utilized to move the vehicle. But in case of hybrid electric vehicles, we have a power split device available there, which will take power from the combustion engine as well as from the electric traction motor and use either any one or combined both. So it will use petrol or electric motor, or it will use both of these to power the driving wheels. Now how this is done we will see in the next videos. Thank you. In this video, we are going to see various types of hybrid electric vehicles. So majorly there are three classifications. One is series, one is parallel, and one is series parallel. In the difference between each one of them is how the power is transmitted from the available uh, propulsion sources, either the prime mover or the prime mover, either from the combustion engine or a petrol diesel engine and electric motor. So or combined both. So how these things are done we are going to see. So this is the first architecture. Now this is the series. This is the first architecture for the series hybrid electric vehicles. So now in case of this series hybrid architecture, you see here this is the one energy source and this is the another energy source. So we have two energy sources here, and then we have two prime movers as well. So we have the IC engine and we have the motor. Okay, so they both can provide both can convert uh, energies. So in case of IC engine it will convert the chemical energy of fuel to mechanical energy, and in case of motor it will convert the electrical energy from the battery pack to the mechanical energy. So why this is called the series hybrid structure. So you see here the IC engine is not involved in traction at all. Okay, so the IC engine is doing is it is using the fuel to run a generator, and then the generator is generating electricity utilizing through the power conditioner and recharging the battery, at the same time providing current, provide voltage and current to run the motor as well. So the motor is then connected to the transmission. So you see here the flow of energy is from the fluid. So the fuel is in the fluid state, and then uh, it is assigned to the IC engine where it is being converted into mechanical energy. Then at the generator end the electricity is being generated and then distributed to the battery and motor. So the electrical connections, and then we have a mechanical connection between the motor and the transmission if we have. So this type is the series hybrid, and the IC engine does not take part in the propulsion of the vehicle. IC engine will not take directly part on the propulsion system. So it will generate the electricity needed and then send it back to the power conditioner. So then depending on the requirement, power conditioner will send electricity to the motor to be converted to the mechanical energy, and it will send the remaining power, remaining electrical energy to the battery pack to make for the storage to use on the later stage. The next one is the parallel hybrid electric vehicle. So parallel structure for the storage to use on the later stage. The next one is the parallel hybrid electric vehicle. So parallel structure architecture. So now in case of parallel architecture, you can see both. The next one is the parallel hybrid electric vehicle. So parallel structure architecture. So now in case of parallel architecture, you can see both of the propulsion units we have will directly power the driving wheels of the vehicle. So here in case fuel being converted in the IC engine and then used for the propulsion of vehicle, and here at parallelly we have the electrical setup. So the battery pack, the power conditioner, and the motor. The, they both work tandemly using controllers, the engine control units, and then depending on in this case they can they can either provide the necessary power independently, or they can work in tandem to, uh, to provide the necessary traction to the vehicle. So the motor is powerful enough, and as I said, in case of a few hybrids, we use the motor to for the starting purpose, and then the IC engine takes over. So this portion will be utilized for the initial 20-30 kilometers, and once that part is done, the IC engine will take over, and then the propulsion will be carried out by the IC engine only. Now the third architecture is the series parallel hybrid architecture. So it will be a mix of both of these. So the series architecture, the parallel architecture, and now when you combine them both, you get the series parallel architecture. So in this case, IC engine can drive. IC engine will drive the can drive the driving wheels. IC engine, the remaining power of the IC engine will be sent to the generator, and then there it will be converted into electrical energy, which will be stored in the battery or utilized by the motor. So what happens here is, in case of this one, the IC engine will operate at a much higher operating range. So when I say higher operating range, it's optimum range, so where the maximum fuel economy is available in case of the IC engine. And now the whatever the extra power at that time, so say for example we are cruising at a 40 kilometers per hour, and then the IC engine is utilizing a very optimal say the IC engine is utilizing an optimal power range. So at 40 kilometers per hour, we don't need as much as power when as compared to the 80 kilometer hour mark. So we need almost the same thing. Uh, so the remaining power which is being generated, which could have been utilized if we were moving faster, now will be sent to the generator unit to convert that mechanical energy into electrical energy, and that will be stored into the battery. And again, if required, the motor can drive the energy from the battery source, and then utilize it is for the transmission. So let's try to I'll try to explain using an example. So in this type of units we have a motor and generators. Okay, so what will happen here is, so say let's say example of the very latest example, the Honda City hybrid, or a Honda City EHEV as the company says. So what is there? There is an IC engine, a petrol engine, then we have a generator, and then we have a motor. Okay, just very similar to this one. And then at the very beginning, so below 15 kilometers per hour, all of the propulsion is being taken care by this motor. And then once it reaches 20 kilometer per hour mark, IC engine is started, but the IC engine is moving the vehicle, but whatever the remaining extra power is being generated at the end of IC engine will be sent back to the generator, which will be used to charge the battery. So this is type of a pure hybrid vehicles, the last one we saw here. And as I said, we don't have a charging port here, so the battery size of the traction battery is comparatively small to the plug-in hybrid electric vehicles. So this is a type of a strong hybrid architecture. Yeah. So we have seen three architectures: the series, the parallel, and the series parallel hybrid architectures. This is an EV model. Uh, so the we are going to do something like this in the MATLAB and Simulink, and then this is the drive cycle we will be using. So at the time we will be doing this EV modeling, we will explain drive cycle to you. But for now, you can just understand that these are the velocity profiles with respect to time. So the peaks and crest you see here, these are the velocity profile. So this blue line. So what is happening here? Vehicle is moving from 0 to 5 meter per second, maintaining a steady speed there for a few seconds and then dropping down. So decelerating, then again accelerating, then again maintaining some steady speed and then decelerating, and this is happening again and again and again. Okay, so this is the concept of a drive cycle, and these are the few components which uh, the parameters and values which we will be going to use to model this vehicle in the MATLAB and Simulink. Thank you.